and so without any further ado, I'm going to hand over to my Good afternoon, ladies. Can you see my screen? Yes, we can. Okay. It's very nice to actually say good afternoon, ladies. I usually start with ladies and gentlemen. So this is a first for me. Thank you for joining this session. I'm one of the lecturers at Mechanical Engineering, and I'm going to present a quick background on what mechanical engineering entails and what are the different routes that you can follow. There's also a link here to the NWU website, a small short YouTube video of mechanical engineering, which you can also view later on. So before I start with mechanical engineering, let's just think of what are engineers. And a lot of people, while you're in high school, people ask you, are you good at science and math? And if the answer is yes, people say that you need to study engineering. However, for me, science and math is just tools, but you have to be someone that identifies a problem and then use those tools, the science and the maths, to solve your problem. And so you actually, as an engineer, you must be a problem identifier, a solver, and you must be able to use these tools and skills. So not only science and maths is required to become an engineer, but you also have to think creatively, and you also have to have good people skills. So that's really important. If you think about studying engineering, think of your personality, think of if you're creative, then it will definitely benefit your science and maths skills as well. And the other thing is, there's not really memes for engineers because as Marnay did, I jumped over from chemical engineering to mechanical engineering. So don't be narrow sighted when you go and study for a specific discipline, because as an engineer, it means that you're already a jack, or in your case, a Jill of all trades. So I also want to pause a little bit on the process, the thought process of engineers. We will start here. And as I mentioned, typical engineering personalities will always ask why. For instance, let's take the problem of, you identify a problem of potholes, for instance. You see that there's potholes, there's an issue, we need to solve it. So then what you do is you then go and you think of different methods and different ideas and different creative solutions to this problem. And then after you've done that, you take the skills that you have, the maths, the science, the software, all the skills that you've maintained during the course of your studies, and you create a plan. Some of the projects will entail a part where you have to actually create something. Let's say you decided to create an alternative tar to fill the potholes with, which is cheaper and it lasts longer. Then you have to actually go and create it. And after that, the process is not complete. Then you test it, and sometimes you find out that there's some things that you can still improve on. And then this whole process continues and continues until you are at a point where you're happy with your product. And there's always room for improvements. I mean, people designed the internal combustion engine way back when, and even till this day, we still improve on the car's efficiencies and the power and the shapes of the cars and so forth, and the weight and so forth. So if you're someone that likes to think in this process, it's also a good indication that you will become a good engineer. So let's now go into mechanical engineering. For me, mechanical engineering is one of the fields that overlaps with most of the other disciplines, such as civil, electrical, chemical, and industrial. So if you're someone that you're not sure where to start, I think it's best to start with mechanical engineering. And mechanical engineers usually have a broad understanding of all the different subfields. You have to know some electricals, you have to know some chemistry and combustion, you have to know structures, you have to know processes. So all of those things are important for a mechanical engineer. Where do mechanical engineers work? Well, I've put a lot of pictures here, but you can work in agriculture, aerodynamics for airplanes design, in the mining industry, whether it's coal or gold or platinum or any of those, in energy such as Eskom, coal power stations, or even nuclear power stations. Then you can also work in manufacturing. That's a large part of the industries in South Africa, such as many industries that produce products and food products like SAP. And then a lot of engineers also work in heating and cooling, or what they call HVAC, in air conditioning systems. All the mechanical engineers designed these systems also way back when, and now we just implement them. And you can work at processing plants such as Sasol, and this is a plant at CFAM, which we'll show later on. And then you can also work as a consultant for consulting firms such as Intech Industrial or Hatch or Oricon, and they will service either one of all these industries. And sometimes consultation also requires some designing. So people that like to design like to end up there. Okay, so inside mechanical engineering, there are two large legs of mechanical engineering. You have your classical mechanics, and that is the typical picture that most people imagine in their heads. They imagine somebody that works on an engine, or someone that likes to fasten nuts and bolts. However, that's just the one side. So they look at materials and manufacturing and machine dynamics. However, the other side of mechanical engineering is thermal fluid sciences, where you look at energy and heat and work, that's in thermodynamics. And then you look at fluid flow, for instance, making your car aerodynamic, or looking at pumps and pressure drops, stuff like that, and also transferring the heat, let's say at a coal power station, to generate the electricity that you get. So this is more the rough and tough side of things, and the guys like this part, but there's also a lot of girls that like the classical mechanics, whereas some girls prefer the thermal fluid sciences. I'm working in this area here, and I know Marnay, that's going to talk later, also prefers this side, the blue side. And then something else that I need to mention is that we also offer another course, which is called electromechanical engineering. That course is shared between us and the School for Electronic Engineering. So half of the courses you will focus on mechanical engineering, and the other half will be at electrical engineering. So that is also a nice blend if you're interested in both. And then why do you want to study mechanical engineering at our university, at the Northwest University? Well, we have a few exciting projects, exciting things happening in and around the university. For instance, we do a lot of research on sailplanes, and there's a company based in Potchefstroom, Jonker Sailplanes, that develop state-of-the-art, world-class sailplanes that actually win. Most of their clients are European clients, and their planes have won various competitions in the past. So they actually come from the small town of Potchefstroom, but they're actually worldwide known for what they do. And you can do a lot of things. They look at the thermodynamics, but they also look at heat transfer. And this is a small fan that will just help the plane get into the air. So this is, if you like the aerodynamics, you will definitely find projects that do offer bursaries for master students and some work experience as well. And then we currently have the solar car challenge. It's a part of the whole faculty. But at this moment, we have it at mechanical engineering. So this is also a nice problem because it has electrical engineering, civil engineering, a lot of mechanical engineering and solar engineering. So we are currently busy upgrading it. The top picture was one of the oldest designs. I think we won a lot of prizes with this one. And then it developed in a few generations. The one at the bottom right is the one that we currently building, and we're going to plan. Due to COVID, there was a few delays with the actual competitions, but they plan to take part in competitions soon. And then we also have another company in Posh called CFAM, which is a food production company. They take these raw fruits and materials such as mealies and coconut, and they put it through an extrusion process to produce products such as knickknacks and cocoa pops and cereals. So there's a lot of opportunities in the manufacturing of food, and a lot of research being done there as well. So it's research and it's industry. And then another exciting thing, what we have at mechanical engineering is additive manufacturing. Now, Johnny Fourie will tell us later on more about that, but it's a whole new field that developed since they discovered 3D printing. So they can make a lot of designs better and improve the manufacturing process and do things that we could have done in the past. So that's also something that you can specialize in if you want to study further. So what can you expect during your studies? You can expect to be exposed to numerous fields of engineering. And during the course of your studies, you will get tools and learn new tools. Those tools are typically simulation and modeling with software, different softwares in different fields, and you will learn how to design, you will learn how to manufacture and analyze. So this all will give you enough tools to actually go out there in the industry and start contributing to society. So I've touched on these. Where can you study further? There's the aircraft development. That's one of the groups. And then you have material and vibration analysis. Then there's another research group, additive manufacturing. You have the hydrogen, which you can also do further studies on, and then thermal fluid systems and design, which is also a lot of processes needs to be optimized, and there's a lot of room for improvement there. But you can also follow this link to the page to see what are your options for masters or PhDs at mechanical engineering. And then finally, why should you as a girl, study mechanical engineering? Now, if you look at this picture, on the one side, you have a male sitting on a green chair, and on the other side, you have a female sitting on a red chair. And we all know by now, men are from Mars and women are from Venus. However, both sides and approaches are required for the workforce. We think differently than they think. However, there is no superior thought process. I think actually, if we put our heads together and we have the perspective of a female and the perspective of a male, we can provide better solutions in the end. So that is the story from my side. I think I'm going to give over to Johnny, and then we can take the questions after the speakers. Thank you.
Just before John starts, I just want to remind you that you can type your questions along in either the chat or in the WhatsApp group. If you type it in the WhatsApp group or on the YouTube link, I will paste it here so that the speakers can see it. So you can ask your questions along in writing, even though John Ree is speaking so long.
Okay. I can't find my mouse. Okay, I'm sharing my screen. Can you guys see it? No?
Yes, we can.
Can you see? Okay.
So,
So, good afternoon, ladies. I'm John Ree, and I'm a postdoctoral fellow at the Department of Mechanical Engineering. So, thank you for this opportunity to present some of my research that I'm doing at the Additive Manufacturing Research Group. Okay, so I'm going to start off by telling you a little bit about myself. I see my education like different pieces of a puzzle that have come together. So I started my BSc in biochemistry and physiology, followed by an honors degree and master's degree in biochemistry. I've always had a keen interest in the field of biomedical sciences, and I'm driven to improve the living standard of people facing medical challenges through my work. So with this in mind, I chose to do my PhD in a multidisciplinary approach where I combine fields of biomaterial development, tissue engineering, and additive manufacturing, which led me to mechanical engineering. So in my PhD, I developed a biopolymer blend that is 3D printable and can be used in bone tissue engineering applications. So my research mainly focuses on bone defects. And finding alternative treatment options. So after severe trauma or the resection of large tumors, the defect site exceeds a critical size, and this defect will be unable to heal via the normal physiological processes of the body, requiring additional material to fill that gap. Okay, so current treatment of these defects are bone grafts and metal implants, but they come with considerable limitations. Therefore, this brings us to the tissue engineering approach. So the concept of tissue engineering is the combination of a scaffold, which is just a 3D porous structure that is combined with cells and bioactive molecules. And this scaffold is then inserted into a defect site that is actually a template to which that can promote the regeneration and repair of tissue within that defect site. Okay, so these scaffolds are fabricated using biomaterials. So what is a biomaterial? It is a material intended to interface with biological systems to evaluate, augment, or replace any tissue, organ, or function within the body. Now, these biomaterials can be natural polymers, ceramics, and also synthetic polymers, or even a combination of them. So for bone tissue engineering, these scaffolds have to meet certain requirements. Now, these include they have to be biocompatible. They should not invoke an immune response. Biodegradable. So after a certain amount of time, there should be no trace of the implant left. Porous, so that you have oxygen, nutrient, and waste exchange throughout the scaffold. Mechanically strong to withstand the pressures within the defect site. Controllable swelling, osteoconductive, and bioactive, so that the normal function of bone can be restored. Okay, so these biomaterials that we develop is specific to be 3D printable. So why do we want to use 3D printing? So additive manufacturing is just a fancy word for 3D printing. So why do we want to use it? Because you can take the CT scan data of a defect site there, and then an implant can be designed and manufactured to the precise geometry of that defect site. So ultimately, you have a patient-specific implant for each specific defect. Okay, so these scaffolds are fabricated using additive manufacturing, and there are two general approaches. So you first have the conventional approach, where the scaffold is fabricated using a wide range of biomaterials, and then the cells are seated on top of the scaffold. Now, the second approach, which is bioprinting, which is a newer technology within additive manufacturing, is a hydrogel, for example, can be mixed with cells to form a bio-ink, which is then bioprinted into a cell-laden scaffold with cells evenly distributed within the scaffold. Now, this will allow for more uniform tissue ingrowth, so ultimately for faster healing times as well, because you have cells secreting an extracellular matrix throughout the scaffold and not just on top. Okay, so this brings us to what we do, or what I do at the Additive Manufacturing Research Group. So my focus is more on the development of biomaterials. Firstly, for the tissue engineering approach that we just spoke about, where the scaffolds are resorbable, but we are also developing biomaterials that can be used as complements to permanent implants, such as cobalt chrome that we do at the Northwest-Universiteit. We specialize in dental implants using cobalt chrome, like I said. This is a dental bar, as you can see. And then one of our collaborators at the Central University of Technology, which focuses on titanium implants. So we are focusing on, firstly, developing biomaterials that can be used as coatings to these implants. Implant-related infections is a major problem in orthopedic surgery, and antibacterial coatings can potentially prevent them. And then secondly, we are looking into the possibility of using biomaterials as fillers in these titanium cages, 3D printed for mandible reconstruction. Okay, so that is all from me. Thank you for your time, and we hope to see you guys in the future. And I don't know, I'm handing over to Marnay, or we're still first taking questions?
I think
there's
there's one question directed to you now, John Reed.
Okay, let me just stop sharing my screen. So I can see the chat. Sorry.
I can read it to you if you like.
Yeah, okay, I'm here. No, so for the resorbable scaffolds or the tissue engineering approach that we are following, it's biodegradable. So your body will take over that process. So you're only giving it a template onto which the cells of your body can attach and reabsorb the scaffold. So that's why it's biocompatible and biodegradable. So there's no removal. So there will be no second surgery. So we want one surgery, one and done, and the healing commences after the initial implant. Thank you for the question. It's my pleasure. Thank you, Nina.
Okay, Marnay, take it away.
Okay. So hello everybody. I'm Marnay Jordan. Actually, I sent him my surname wrong. I'm Marnay van die Kerk. I recently got married, so sorry for that. But yeah, so for me, engineering is just to kick off in the sense, as Dr. Marina also said, engineering is a wide, how can I say, it's a wide category of, how can I say, a career path, in the sense that everything that you see and touch, and even on like software, Microsoft and everything like that, an engineer was involved with the process of making it or developing it. For instance, Prof. Lenta developed that Chop app. So it's just an example of, if you study engineering, it's not a concrete, if I study mechanical engineering, it's going to be black and white. There's lots of gray areas, if I can say it like that, in the sense that you jump from one side to the other. And for me personally, engineering is how can I say, if you study engineering and you complete the degree, it learns you a way of thinking, in the sense that it gives you the ability to research and to apply that research in the field. So a little bit of the background of me is I'm born and bred in Potch, so I'm a proud Potchefstromer. And for me, my whole family is medical doctors or is in the medical industry and agricultural. So there was no engineer for me to actually go and communicate or just see what an engineer does. So for me, it was a very, how can I say, a gray area in the sense that I didn't actually know what an engineer is or do. But at the age of 18, I did know that I love the environment, I love animals, and I also love problem solving and mathematics. So I went for the aptitude test, as we all do, and it came out that I should become a chemical engineer. So I didn't know any chemical engineers. I didn't know what a chemical engineer is, but I signed up for the Northwest University. And why I actually chose the Northwest University, just to give a little bit of a reason why, is for me and also for a lot of the people that I know and my classmates, the student life here at the PUK is just, I'm going to say it's something else. You feel safe. It's nice. It's an actual student life. It's not like for my one friend that studied in the other university in Pretoria, she said she wishes she could have studied at NWU because of the student life that we have. And another thing that for me that stands out of the NWU is you're not just a number here, in the sense that you actually build a relationship and how can I say, a mentorship with your lecturers, and they help you, and there's communication and there's assistance. So that's why I'm an ambassador for the NWU as well. So with me not knowing actually what engineering is or what engineering or engineers do, I started studying chemical engineering in my first year. And after my first year, I decided for several reasons, I want to study industrial engineering. So I studied industrial engineering in my second year. And then in our second semester, I was introduced into thermodynamics. And I completely fell in love with it. The whole thing about mass and heat transfer, I just loved it. So that's how I became a mechanical engineering graduate, if I can say so. And after my undergrad, I did my master's in simulation and 3D printing. I actually did my undergrad also in 3D printing, so that's why. But 3D printing is very, very interesting. It's also it's now also a hot topic in the world now. And as John said, there's a lot of mechanical engineers are the front runners, if I can say it like that, for 3D printing. But for me, another reason why mechanical engineering was actually a nice fit is because it has a wide variety to applications or to career choices, in the sense that you can, from my classmates, you can go from explosives to mining to aerodynamics to consulting and everything in between. So for me, as I said previously, it's not about I'm a mechanical engineer and I'm going to do just design or anything in that sense. Typically, if you're going to become an engineer, they're going to expect you to do either A, B, and C, meaning you have to know a little bit of this and a little bit of that, and you have to apply to what the client wants. So after I did my master's at the NWU, I actually, we all know that women can multitask. And in my first year in this year, 2021, for the first 4 months, I actually did 2 jobs. I was a mechanical project engineer, or junior mechanical project engineer for a mining consulting company. And also I worked at Raventech Consulting, where I'm currently now. So that is just, I think, I'm not sure if I can say it's a woman thing, but that was very, very challenging for me. But I did it and I did it well. So I'm glad for that. But we here at Raventech Consulting, what we do is everything energy, if I can say it like that. So from fuel efficiency, in the sense that we go to clients that use bulk consumption of fuels, like your transporters or mining or anybody that uses generators. We use an additive and we implement it to the fuel storage of the client. And then we will also monitor that project in the sense that we will give them feedback reports about how much they saved and everything in that sense. So that's the fuel side that we do. The other side is the integrated energy solution. So that is everything from solar to wind to hydro, and also from energy efficiency in the sense of adjusting your HVAC or adjusting your water heating, cooling system or heating system, and also the lighting and everything. So typically what the company does is we would go out to a client, we do an audit about how much energy the client uses, and then we would come back, process the data, give almost like a projected view of what the project will be and how much it will cost, like a projected budget. And then the client will either say yes or no, he wants to go forth with it. And then we will do project management. So that's why our consulting firm is very much project management orientated. But what I currently do at the company is basically hydrogen, hydrogen integration and hydrogen storage and the implementation of hydrogen energy with various energy sources such as renewable energy or nuclear or grid, and especially with remote mines. So that's what I'm currently busy with, and I'm busy doing feasibility studies with that and researching and learning a lot about a whole new field that I did not actually think I would be open to. But yeah, that's what I do currently from day to day. So what made me choose to do engineering is actually, engineering is, the solution to the problem that is currently, we have an energy problem worldwide, in the sense that fossil fuels are it's going to be eliminated maybe not in our lifetime, but it's going to be, it's not a renewable source. So I wanted to be part of that solution. Even if it's just a tiny sand grain in the beach, I wanted to be part of it. So that's what actually inspired me. It's not a specific person, it's more the globalization and the global problem that we currently are in, and how I can maybe help somebody. And especially in a world where, like South Africa, we have energy, as you all know, with load shedding. Energy is a necessity. So how can we or me or my research actually help a community or South Africa to grow further? So that's why I chose to become an engineer. I want to make the world a better place. I know it sounds kitschy, but that is what I believe an engineer can do. And I love research and I love problem solving. And that is why I'm going to do my PhD actually under Dr. Marina next year in hydrogen and energy. So, but if I can give any advice for girls or girls that you're thinking of studying engineering, is go out and find a person. It doesn't have to be a relative. It doesn't have to be somebody that you know. You can just contact a firm and ask if you can shadow an engineer for a weekend or a week in the vacation. That gives you a little bit more understanding of what I want to almost say signing up for the rest of your life, in the sense that it gives you a better knowledge of what you think you are going to do. For me personally, I thought a chemical engineer is somebody that is going to work in labs, and maybe there is, but my perspective of a chemical engineer was totally different from what I actually found out in my first year it was going to be. So that is one of the reasons I changed. And that's why I would pursue you guys to go out, meet. You can contact me if you want to, and go out and go survey or shadow an engineer and just see what their day-to-day life is, because in the end it is going to be your 8 to 5, in the sense you have to like it. It has to be your passion. And if you can do your passion from 8 to 5, I think you're really blessed. So, and also, as Dr. Marina also pointed out, I see now also in the industry women and men do differ in the sense of thinking. And I think it's a good thing that more women are actually in the industry. And I hope that more women can come in. And also one of the, I think, role models, if I can say it like that, or somebody that I aspire to actually be like is, I don't know if you girls know, but CEO of Anglo Platinum is a woman, Natasha Varun. She's a former NWU alumni as well. So yeah, that's just show you that if you're anything capable, if I can say it like that. So yeah, that is my story. And yeah, I saw these questions. I think I missed them. So I'll just go and see for where the chats are. So let's see. Okay, that was for, okay, okay, that was for John Ree. Okay, or does NWU offer aerospace engineering? If not, where can I study it? So aerospace engineering, Jonker sailplanes, that is a major aerodynamic, how can I say, research group. I'm not sure. There's a different, I think there's a different line of aerospace in the sense that you can do either aerospace where the Jonker sailplanes are going to be focused only on, I think only on sailplanes. But if you want to go into other forms, I'm sure there's still, you can definitely do it at NWU. I know there is in the mechanical, you have to choose between failure of materials and aerospace in your final year. And you can just choose aerospace engineering. So you're still a mechanical engineer with the speciality of aerospace. And do you need to be familiar with bone? And that's Johnny's, that's Johnny's question again. What are the requirements?
Can I maybe just add to what Marnay said about aerospace engineering? It's more specialization. So you probably do your undergrad in a typical mainstream mechanical engineering school, and then you would do a master's or a PhD at a project on aerospace engineering. If you want to, for instance, design the combustion chamber of one of the rockets for NASA, then you have to find bursary, go to one of the universities in America and then in the USA, and then do a project on that. So it's this, I don't think you can just study undergrad aerospace engineering. You have to find a basis of mechanical and then move on to that. So I think that will also answer the other question about what are the requirements. I think the requirements would definitely be at least a degree in mechanical engineering before you then go and specialize further.
But also, I don't know, Doctor, if in the fourth year, I don't know if it still is like that, you have to choose between failure of materials and aerospace.
That recently changed. They actually absorbed some of the aerodynamics into another course.
Oh, that's nice, actually, yeah. Because I chose failure, so I don't have any aerospace knowledge. And then I
think the rest is for John Ree.
Yeah. I don't know if John is still here.
Yeah, I'm here.
Well.
Okay, so the first question was, what do I love about tissue engineering? What have I done so far and how did I discover it? So I think I was at the right place at the right time. Okay, let me start with what I love about it. So I think it gave me the opportunity to work or bring different fields together, like from additive manufacturing, tissue engineering. I come from a biology background, so I'm applying my biology skills to an engineering problem as well. So I think the multidisciplinary nature of tissue engineering as a whole is what attracted me to it. I had a postdoc at biochemistry that I met through another professor, and he took me to Prof. Dion, which is like the father of additive manufacturing in South Africa. And I had a meeting with him and he told me about the project, and I just couldn't say no. I wanted to go start my career in industry, and he just convinced me to do the PhD in this, which I'm very grateful for, because I actually found my niche, can I say, where I want to build my career. So yeah, I think that is how I discovered it. So for now, we actually are busy with the coating. We have the biopolymer blend that is 3D printable and is biodegradable, biocompatible as well. So we have to design a 3D printer that can print that specific material, because everybody thinks a 3D printer, you just stick a material in it and it builds this amazing thing. That 3D printing is still in the early stages. There's a lot of research that still needs to be done. It's kind of in the beginning phases. It's not perfect yet. So we have to build a 3D printer for that specifically. And then we are just busy with the coatings. We have a big project that's starting next year with ceramics and adding that to metal implants. Okay, and then the other question was, do you need to be familiar with bones going to bone tissue engineering? No, you don't. I think like I started from a biology side coming to mechanical engineering. So I do think you can go from mechanical engineering into the biology side of things. So I'm learning as I'm going the engineering side of things. But there's a lot of engineering problems within bone tissue engineering that you don't have to know exactly what's going on with the biological processes that actually what goes on into that. You are going to be mainly focused on the fabrication and the problems that arises with the material after it's been fabricated and before it's been fabricated. So I don't think that you need to have extensive knowledge on bone. That's also something you can just read, and you'll be doing the problems from the engineering side if you are a mechanical engineer. So it's a great field again, because it brings a lot of disciplines together, so we can solve everyday problems using multiple people in the room. Yeah, I think that's all my answers. Okay, Marnay, there's a question for you.
Yeah, so that is the renewable projects that has been launched. I hope actually that, if I'm correct, as I said, my feasibility study is mainly hydrogen, but the IPCC, I actually followed it, or I have read about it. And I think actually I want to say for Eskom, especially with the Medupi that has been exploded. So for I think if they do the IPP and the IPP projects, and if they do it well, it can actually help and generate more electricity and actually reduce load shedding. So I think the renewable energy does have a place in the world, but for me, I believe in a hybrid solution. I don't believe in just renewable energy or just nuclear or just grid or hydro or whatever. I believe in a hybrid solution. So nuclear has its backdrops or its downsides, and renewable also, or PV actually also has its downsides, in the sense if the wind is now blowing like crazy in Porch, but if the sun doesn't shine, there's no solar, there's no electricity. So for me, it's a hybrid solution for everything is a better solution than just I'm going to say pure solar or pure hydro solution. So I hope actually that the IPP and all the other agreements that they can actually, I want to say, integrate a little bit. I saw that they're actually going to be more nuclear. I think there was a budget of 50 million that they are going to make, how can I say, available for nuclear. In the sense that maybe I hope the nuclear community and the renewable community can see eye to eye and actually work together to help in South Africa with its energy problems. So yeah, I think renewable energy definitely has a space, and it's growing, and it is a very, very interesting field to be a part of. But yeah, I'm more of a hybrid, if I want to say it like that, a front runner or advocate. So I hope that answers your questions, Nicoline.
Okay, I think that is a yes. Um, all right, is there any other questions that anyone has that you would like to ask? Okay, I think I would like to highlight once again that remember that all of the disciplines work together to make things work, and that the one cannot really exist without the other. So a significant portion of the things that I do is actually aimed at, or is mechatronic systems, where we select or design some mechanical systems or mechatronic solutions for medical problems. And on the other end, we are connecting devices to the internet, which is also then a cross-disciplinary field. So there's no clear distinctions between the different disciplines, and we all need to work together. So remember again, before we move on to the hands-on project, that the admission requirements for engineering is 70% for both mathematics, that's pure mathematics, not technical mathematics, and not math lit. So pure mathematics 70%, and then also remember that your languages are important. So either Afrikaans or English is 60%, and then remember that we have some backup plans as well if you don't get into the program originally. So we shared all that information with you, and we will once again share it with you in the WhatsApp groups also. So Marina, John-Lee, and Marnay, I'm going to ask you in 1 minute's time for some parting words from each of you. But a last word from my side is that I really hope you enjoyed this week with us. I hope you learned a lot. I hope you feel more enthusiastic about engineering and the different possibilities within the field. I hope that you can make some informed decisions after this. Okay, I see there's a question. What is EGD? Is that engineering drawings? Okay. We called it technical drawing when I was. Okay, so let me quickly maybe answer that question for you. I'm doing a time-taking subject called EGD, and I'd love to know courses related to it. So I think that's engineering drawings and mechanical engineering and computer and all of the programs within electrical, electronic, and computer engineering, mechatronic engineering, and industrial engineering all take those subjects in the final year of study, in the first year of study. We just don't necessarily use it equally as often past the first year. Mechanical engineers take a computer-aided design course for 2 semesters, while the rest of us do it for a single semester. The hands-on project that Karen will be doing with you later today will also teach you some of the basics related to very, very basics of computer-aided design. But yes, I as a computer engineer and a product development specialist actually use mechanical drawing much more often than many of my other computer engineering colleagues. So it really depends on what you are doing and whether or not your project needs it and who you have on your team. but I think it's always good to have subjects like that. Nina, you asked, or you said, thank you very much for your time and effort. We hope that you also enjoy your weekend, like you wished us. Yeah, engineering, graphic designs, EGD. I learned a new subject. Marina, did you know that that subject was called that? Okay. Then, yeah, I'm going to switch to Marina and Jean-Henri for some parting words, and then I'll say the final goodbye until we, and then we will switch to YouTube for the hands-on project this afternoon.
Thank you, ladies, for joining this afternoon. I hope it was informative. I hope you come and join the Northwest University. Doesn't matter where you end up in terms of which discipline. I would just like to encourage you not to be scared to pursue engineering. In my time, when I studied engineering, which is not that long ago, but it's still long ago, the numbers were quite a few. And you can feel scared because you don't have fellow friends that are studying with you or people that you can ask. But I want to encourage you that more and more girls are joining us, and even the guys studying with you, they are quite helpful, and you take hands, and the girls help the guys with certain projects and the other way around. So don't be intimidated by the current gap. Because more guys study mechanical engineering. Don't let that be a deciding factor for your studies. Thank you.
Okay, so my parting words. Thank you guys for joining this afternoon. I think my parting words would be, you guys are in the beginning, like enjoy it, choose wisely, and plan your career from the start. I think that would be my advice. Plan it from the start, and if you're not sure, find out. And yeah, come and study here. We will be happy to have more girls on campus, especially at the engineering department. It will be lovely to have more girls. So good luck with the rest of your school career, and then we look forward to seeing you guys in the future on campus.
Okay, Marina, your turn.
Oh, sorry. Yeah, my parting words would just be, if you did yeah, I hope you guys choose engineering to study. And if you are not sure about what to study, and you feel like you have to change courses from chemical to industrial to electrical to mechanical, don't be afraid to do it. I did it, and a lot of the people, they gave me a little bit of frowns and everything. But I think, yeah, so engineering is fun, and it's a challenge. It's very, very, very much fun. It is hard work. And the only thing that I think you should need for studying engineering, minus the administration point, is self-discipline. It's all about self-discipline. If you have self-discipline, you are, I think, halfway there in completing your engineering degree. So, and actually, I remember one of the admin dames, she told me that more women or lady engineer, mechanical engineer passes the undergrad than men. So yeah, we have a higher pass rate. So I hope to see you guys, and you are more than welcome to anytime contact me with any questions. And I saw the one guy, or one Karen Skutte, you asked if South Africa is still using coal. Yeah, we are still using coal, unfortunately. There's very much IPP projects, and the government is trying to pursue or to initiate more renewable sources, in the sense of pursuing the mining industry and the industrial industry to get off the grid and do solar and renewables. So there are plans in place, and I actually have a good feeling for South Africa in that sense. So yeah, that is my last words.
Cool. Thank you so much, ladies. I see there's one final question from Ritzipile saying, I'm an individual who is able to look at something and instantly come up with how to improve it. which engineering fields should I pursue? Any of them, all of them. That's what engineers do. We find ways of improving things and improving the lives of others. So it really doesn't matter which discipline you choose. It doesn't matter what you choose to do, as long as you apply.
Enjoy.
Yeah. If you apply things into a field that you're really interested in, so that you can enjoy it. I love my job every single day. I promise you, I wouldn't have spent so much time with you guys on screen if I didn't love my job. And I definitely wouldn't have gone to work every single day feeling like I am being spoiled for getting to do that as a job. So at least, whatever you do, you should feel that way about the job you're doing, because then you won't work a single day in your life. You will just get to enjoy every single day. And actually, I know very few engineers that don't feel that way about their jobs. It's maybe a transition phase where they're maybe not accustomed to their industry yet, or that they're in a job for now, but they're still looking for that perfect one. But most engineers really love what we do, and we love it every single day. And that's why we always talk about work when we meet with others. It's because we like it that much. So it's not because we can't speak about anything else. We're just that excited about what we do. So I really hope you enjoyed this week. I hope you enjoyed today. I enjoyed today. We will now move to YouTube, where Karen will take us through the hands-on project for today. I hope you draw along, and remember that if you draw your snowman and you send us your design files, we will 3D print it for you and send it to you. So it's worthwhile to actually do it and try your hand at it. And it's not an intimidating interface. So really try. And yeah, if you have questions, ask them on the WhatsApp line, and we will try, or the WhatsApp group, and we will try to answer all your questions there. But you shouldn't have too many questions, but you will see that it is really fun. I have a few 3D printers, so we will hopefully send it to you within a week of you sending it to us. So really try, and it will be a cool memento for you to keep afterwards. So have a good weekend, and actually have a good year, because I will only be seeing you next year again. And keep being creative, and don't be afraid of trying new things. Goodbye.
Good afternoon and welcome Femmegineering 2021 participants. My name is Karen Skitter and I am a third year mechanical engineering student. I will be presenting this year's mechanical engineering hands-on project, Learn to Draw in 3D. First things first, what is mechanical engineering? Mechanical engineering is the application of the principles and problem-solving techniques of engineering from design to manufacturing to the marketplace for any object. So this process from design to manufacturing to the marketplace is exactly what we are going to look at today. Mechanical engineering combines creativity, knowledge, and analytical tools to complete the difficult task of shaping an idea into reality. Disciplines within mechanical engineering include acoustics, design, aerospace, energy, manufacturing, and additive manufacturing. So today we will look at how to shape our idea into reality by using CAD, which stands for Computer Aided Design, as well as additive manufacturing to shape our idea into reality. So let's explain a little bit about computer aided design. Computer aided design is the use of computers to aid in the creation, modification, analysis, and optimization of a design. And the CAD software that we will be using today is called Tinkercad. So let's jump right into it. In your browser, type in Tinkercad and click on the first link. click on Join Now, create a personal account, and then sign up with your Google account, your Apple account, or with an email address. I have already created an account, so I will just click on sign in. If you've signed up successfully, Tinkercad will let you work through a small tutorial. Please feel free to work through this tutorial, but I will also go through a few steps right now. So when you get to your home page, just click on Create New Design. So here we can see our work plane, and for the first part we're first going to look at the different angles and how the camera works in Tinkercad. So if you scroll your mouse in and out, you'll see that your work plane zooms in and out. This little box here at the top left corner is very handy, and it's because you can view your work plane from any angle. So let's place a cone for now so that we can view our cone from different angles. How do we place a cone there? We click on the cone and we drag it to wherever we want it to be in the work plane. So if we want to view this cone from the top, we just click on top. If we want to view this cone from the front, we click on front. From the right, or from the left, or from the bottom. So let's just get it back to where it was. So we just click on this little line over here. Okay, so we have our cone in the middle of our work plane. Let's see what we can do with our cone. Okay, so if we click on our cone, we can see that we have two options, either a solid or a hole. If we click on a hole, it will appear in this color, and it will basically, in this case, just be nothing. So let's keep our cone solid. And we can change the color of our solid as well. So let's make our cone red. Okay. With these options here, we can change the top radius of our cone to the size that we want it to be, but I'm going to keep it to 0. The base radius, I'm going to keep it at 10. And we can change the height of our cone. Let's just make the base radius 20. And we can also change how many sides we want on our cone. Let's just make it the maximum number of sides, so that the sides are smooth at the bottom. Okay, so this is our cone now. But let's say we wanted to drill a hole through our cone. So what are we going to do? Let's first think, what is the shape of a hole? The shape of a hole is sort of like a cylinder. So we're going to drag our cylinder here. And now we have these two options. So let's select the hole feature. And if we look at our cone from the front, we can see that if we were to use this hole feature, it's not going to cut through the whole hole, through the whole cone. So we need to increase the size of our cone. So what we do is, let's just go back to this view. We take this button and we drag it so that if we look at the front again, we can see that our hole is a bit higher than the top of our cone. Okay, perfect. So what we do now is, let's first make the hole a bit smaller because it's quite big. So let's make it a 10 by 10 hole. And let's drag our hole to the center of our cone. And let's just see what it looks like. Yeah, that looks like it's in the middle. Okay, so what we do now is we're going to group our features so that this hole can cut through our cone. So you just click here and select both of your objects and click on the group option. And then you'll see, if we look at it from the top again, that there's a hole through our cone. Let's just add a box here next to our cone. And we wanted to add another box on top of this box. But if we try to do that, you'll see that it won't stack on top of that box. It will just be to the side or through the box. So what is our solution for that? Let's just delete this box for now. Just press the delete key on your keyboard. What do we do to add another box to this box? We just click on work plane, and then we specify where we would like our work plane to be. So it can be anywhere on your object or on your current work plane, but we want it to be at the top of our box. Okay, so now if you click on front, you'll see that our new work plane is shifted up and it is at the top of our box. So that is the place where if we want to place new objects, it will be at that location. So let's just bring our view back again. Let's just add a scribble. We would like to add a scribble there. Okay, what do we'd like to scribble? Let's say we want to scribble in NWU, and then we click on done, and then NWU will be our scribble, right? Oh, I forgot to add that if you can't zoom in and out with the mouse, you can also press these buttons to the side to zoom in and out if you don't want to zoom in and out with your mouse. Okay, so that is how you add something to another level of your object. That's our work plane. So if I want to go back to our last work plane, or our original work plane, we just click on work plane, and there we go, we are back at our work plane. Okay, I think we're done with this part of the tutorial, so let's build a snowman. So just click on this Tinkercad dashboard button, and it will save your work. So we're going to build a snowman that looks like this. So when you get to the dashboard, just click on create new design, and it will create a new design for you. Okay, so let's think. What does a snowman consist of? Well, if I think of a snowman, I would say that we need 3 spheres. But the spheres have to be different sizes. So let's make our spheres different sizes. So this sphere, we can make it, let's make it 35 by 35. Then we just have to make it higher as well, 35. So there we go, there we have our base of our snowman. So then the body of the snowman must be a little bigger than our base. So let's make it 25 by 25, and just make the height 25 as well. There you go. I think this might be a bit small for the base or the body of our snowman. So let's make it 30 by 30. Just click on that red button and type in 30 by 30 on your keyboard. And then let's just make it 30 in height as well. Okay, so I think this will be good. Let's look at it from the front. Yeah, it looks good to me. And back to our other view. Okay, so now we have the head of our snowman, and I think it will be big enough as well. So a snowman is usually white. I don't want to make a blue snowman, so let's change the color of our snowman to white. There you go. Okay, so now let's put our spheres on top of each other to create the body of our snowman. So what we're going to do is we're going to take this sphere, which is the middle body part, and we're going to press on this button and drag it upwards. Let's just look at it from the left. Okay, I think you can go a little more maybe, and then let's just drag it over and look at it from the front again, and now we see, okay, it can go a little bit down. Okay, but now I see that this body is a bit big and our snowman looks a bit out of proportion. So let's make it just a little bit smaller. Let's make it 27 by 27 and 27 in the height as well. Now we just have to position our snowman's middle body again. Let's just look at it from the left. Okay, we can see it's a bit back, so let's just move it until it's in the center. That looks good to me. Yeah, I think it's fine. Okay, and now let's add our snowman's head. So we click on this black arrow again until it's red, and then you just click on your left view. Okay, I can't click on my left view because I can't access my snowman's head over here. Okay, we just need to drag it a bit to this side, and now we can look at it again from the left. Okay, and I think our snowman's head is a bit down. So we just need to move it a little bit up so that our snowman has a little bit of a neck. And then we can go back to our view, and I think this looks good to me. Okay, so what's next? Let's think. Our snowman probably needs a nose, right? Okay, so what does a nose look like? Well, I would say we can use a cone for a nose. This cone is just the general shape of the nose, but we will modify it now so that it suits our needs. Okay, so firstly, let's make the nose orange because a carrot is orange. And let's make it a lot smaller. Let's make it 5 by 5. And the height must be smaller as well. Now, this is a very fat nose, so let's make it 2.5 by 2.5. Okay, I think this is better for a nose. Now let's place our nose on our snowman. So we drag it up, and then we would like to rotate our nose. So we look at it from this side, we can see that there's an arrow there at the top. We would like to rotate it 90 degrees. So let's just press Ctrl Z because it wasn't exactly 90 degrees. So what I will do is I'll just click there. I'll just click, wait, let me just get the right arrow. Click there. Type in 90, press enter. Type in 90, okay, if it wants to type on my keyboard. Oh, I didn't select it properly. So click there, type in 90, press enter, and it rotated our nose 90 degrees. Okay, so but now our nose is still hanging in the air and it's not attached to our snowman's body, so it has to move a little bit down. And then if we look at it from the left side, we can see, okay, it's far from our snowman's face. So then we just click on it, and let me just zoom in a bit so that I can drag it. Okay, no, not like that, Ctrl Z. Let's try another angle to move the nose. Okay, there you go. I think that is. I think, no, that's our head. We don't want to move our head. We just want to move our nose. There you go. Okay, so let's see how big should our nose be? How much should it protrude from our face? I think that looks good. Let's just look at it from the front. This view. Yeah, that looks good to me. We can maybe move it a little bit up, but we'll see if it works now. Okay, so our snowman has a nose. What's next? It probably needs eyes. So what does an eye look like? We can probably use half spheres for an eye, or you can use a tube, or we can give him star eyes, but I would rather use half spheres. So let's have a half sphere here. And what color should his eyes be? I think they should be black. Okay, so let's shape this half sphere into the shape that we require. So let's make it very small. We can make it 2 by 2. Maybe that would be too small, but we'll see now. And make it a bit shorter as well. I think it can go a little bit more. It's a bit tall still, so let's also make it 2. Okay, that looks like an eye to me. So now we can click on it, press Ctrl C, and click so that it's not selected anymore, and press Ctrl V again. So then you'll see we have 2 eyes now. So instead of taking another half sphere and adjusting its size and changing its color, we can just press Ctrl C, Ctrl V, and then we have 2 eyes. Okay, so let's delete that sphere by pressing delete on our keyboard. Okay, now we need to position these eyes. So if you, okay, let's see. If you click there, okay, wait, let's see. If you position the eyes next to each other in the location that you think, okay, that's not working. Let me just zoom in. In the location that you think the eyes should be. Okay, there you go. So I think they should be there and there. Okay, then we can click on both of them. So if you click on one, you select one, press shift, you select on, you click the other one as well, then they will both be selected at the same time and you can move them around at the same time. So now we selected both, we click on this arrow and we drag them up to where we want them to be. And we would also like to rotate them. So let's go to this view, so that we can rotate them by 90 degrees. Okay, here you go. I think they might be a bit far apart. So let's bring this one closer and a bit down and a bit down. Okay, let's just see what it looks like from this side. Okay, so you see our eyes are a bit too far apart. So let's just click that one, press shift, click on, okay, that doesn't want to work that way. So let's just bring our eyes in a bit. This one as well. Okay, it's not in the right position, so we change our view to place our eyes where we would like them to be. I think it must go down a bit. And this one must also go down a bit. You see this one is too far into its head, so we just move it a little bit out and a little bit down. Okay, and we can move this one a little bit inward. Okay, there you go. I think that looks good for eyes. So let's think, how are we going to make our snowman's mouth? Well, I think we can use the same shape as we used for the eyes, so a half sphere. So let's click on that eye, press Ctrl C again, press Ctrl V, and I think we can add 5 half spheres for the mouth. So we just click there, Ctrl V, Ctrl V, Ctrl V. Okay, so we'll have, I think I pressed Ctrl V 4 times now. So let's see how many half spheres, black half spheres we have now. Yes, 4. Let's try with 4 and see what happens. Okay, so let's take this one, move it up, move it in a bit. Okay, it's not high enough, move it up more, move it in a bit, a little bit higher. There you go. And now this eye as well, or this half sphere as well, move it up a little bit in, and I think it's a bit too high, so let's move it a little bit down, and it can go a little bit in as well. Okay, let's move this one as well. Okay, it's too low, so we move it a little up. I think it's at the right height now, and a little bit in. Okay, and our snowman is starting to get some life. Okay, I just wanted to adjust that eye, didn't look right to me. No, it looks, no. Okay, yeah, that looks better. Okay, and let's just add the last part of our mouth. Move it up and in. And I think it can go up a little bit more, and it can come in a little bit more. Okay, there you go. That looks good to me. Our snowman is smiling and he has eyes. So what else does he need? Let's think. Okay, usually a snowman has a hat, so let's give our snowman a hat. So then you think, okay, what does a hat look like? A hat is a cylinder and another cylinder. And a hat is usually black. So just press shift and select both of them. And let's make it black. Okay, so the bottom part of the hat is usually bigger than the top part of the hat. So let's make this the bottom part and make it a lot shorter. I think 3 would be good. And this part would be the top part of our hat. So let's just make it smaller. I think that might be a bit too small. Let's make it 17 by 17 and see if it works out. Okay, let's make it a little smaller. Let's make it 16 by 16. And I think our head is a bit tall. So no, I pressed the wrong button. Just make it there. Yeah, let's just make it like that. And there you go. Let me just see what it looks like from the front. Okay, so I see it's a bit high. So just click there, drag it down until it is on top of that. Okay, now let's just place our cylinder in the center. Okay, so we just need to move it over until it is in the center. And I think that our hat is still, okay, no, it's not in the center. There you go. No, it's not yet. Okay, that looks better. But I'm anyways going to change it because I think it is a bit too big. So let's just make it 15 by 15 and just place it in the center again. Okay, that looks good to me. Just see, okay, and what does it look like from the top? It's a bit skew. It's a bit tricky to get it exactly in the center, but you can just play around with it until you get it to a place that looks good to you. Okay, I think this looks good. So what we need to do now is we need to group our hat so that we can move it together without selecting it both at the same time. So what we do now is we first gonna select it both at the same time. So you select that one, press shift, select the bottom one. I don't think it's selected. Let's first select the bottom one and then the top one, and then you press group. Okay, now it's grouped. So if you click on it, it will move around together and not separately. Okay, so let's take our hat and move it up and over. Okay, it's a bit too low, so it must go up a bit more. And I think our hat is still a bit tall, so let's make it a bit short. Okay, let's look at it from the front. Yeah, that looks good to me. Okay, so now I think our snowman still needs some hands. So let's think, what is the shape of an arm? It's also going to be a cylinder. So you can make a lot of things from cylinders. And a snowman's arms are usually brown. They're made of twigs or sticks. So let's make it one by one to make it quite thin. Or yeah, I think this is good. And let's add some fingers as well to our snowman. Okay, let's add 3 fingers. And a finger is also the shape of a cylinder. Okay, but I forgot now, I made a mistake. Well, I didn't make a mistake, but I made extra work for myself. So we can just delete these 2 and then copy this finger once we have reshaped it. Okay, so let's first make it round and then make it also one by one. And this finger should be a lot shorter than our hand. I think this finger looks good now. It might be a little bit too long, but let's see how it works and then we can adjust it afterwards. So let's click on it and Control C, Control V, and Control V. So we have 3 fingers here now. You'll see if I drag them apart from each other. Then we can actually, well, coming to think of it, we actually don't need 3 fingers because we can just use this top part of the arm to make the 3rd finger. So let's delete this one and drag this finger inwards and this finger inwards, and now we can just drag it up, can be, and this one as well. I think it can go a little bit more up. Yes, that looks good to me. And now we want to rotate this finger, so let's click on this one and just click on the rotate arrow. If we click on this arrow, let's rotate it by 3 degrees and let's see. Okay, no, that's way too little, so let's rotate it by 13 degrees. Okay, just click on the arrow again, 13 degrees. Okay, I think, okay, we just rotated to the wrong side, so we'll use this finger on the side and this finger, no, we don't want to change its height, so just press Ctrl Z. We want to rotate this finger 13 degrees, but now if we go clockwise, we need to type in -13 for it to rotate clockwise. Okay, so you'll see it rotated clockwise and this one rotated anti-clockwise. So, but I think it is still a bit little, so let's add another 5 degrees to each finger. But remember, this finger must be -5 degrees. And let's just drag the finger a bit in. I think that might be a bit too much, so let's drag it a bit. No, I think it's fine like that. It's fine like that. Okay, so that is our little hand. Maybe we should just drag it a little out. No, then it's not gonna be attached to our arm anymore. No, I think this looks good. Yes, this looks good for a hand. So what we do now is we just select this whole thing, group it together, and now we can move it around. But we need 2 arms, so we'll select it, Control C, Control V, and we have our other arm. Okay, so let's place our arms next to our snowman. And now we can move it up. Move this one up as well. And now we just need to rotate it. Let's take this one. And remember, if we want to rotate clockwise, we need to type in -10 degrees. It's a bit little, let's make it. Okay, just press Ctrl Z. So let's make it 20 degrees and see what it does. -20 degrees. Yes, I think that's fine. Just drag it there. I think it can go up a little. And this arm must also be rotated, but this must be +20 because +20 will rotate it anti-clockwise. Okay, so there you go. And let's move it up as well. Just bring this one a bit forward. And there you go. We have our snowman. So you can play around with Tinkercad. You can draw whatever you want to. The space is yours. If you click here, you'll see that there are many other things that you can explore in Tinkercad. So let your imagination run wild. Try and design your wildest idea, because that's what you can do with 3D drawing or drawing in CAD, computer-aided design. So draw around, play around, and then when you are done, click on export. And once you've exported, so it says download to 3D print. So when you're done with your design, you can send me all your files and we will 3D print it for you and send you your design. So have fun playing around. CAD is awesome, and enjoy the rest of your day. Thank you. Bye. Good afternoon and welcome Femmegineering 2021 participants. My name is Karen Skitter and I am a third-year mechanical engineering student. I will be presenting this year's mechanical engineering hands-on project, Learn to Draw in 3D. First things first, what is mechanical engineering? Mechanical engineering is the application of the principles and problem-solving techniques of engineering from design to manufacturing to the marketplace for any object. So this process from design to manufacturing to the marketplace is exactly what we are going to look at today. Mechanical engineering combines creativity, knowledge, and analytical tools to complete the difficult task of shaping an idea into reality. Disciplines within mechanical engineering include acoustics, design, aerospace, energy, manufacturing, and additive manufacturing. So today we will look at how to shape our idea into reality by using CAD, which stands for computer-aided design, as well as additive manufacturing to shape our idea into reality. So let's explain a little bit about computer-aided design. Computer-aided design is the use of computers to aid in the creation, modification, analysis, and optimization of a design. And the CAD software that we will be using today is called Tinkercad. So let's jump right into it. In your browser, type in Tinkercad and click on the first link. Click on Join Now, create a personal account, and then sign up with your Google account, your Apple account, or with an email address. I have already created an account, so I will just click on sign in. If you've signed up successfully, Tinkercad will let you work through a small tutorial. Please feel free to work through this tutorial, but I will also go through a few steps right now. So when you get to your home page, just click on Create New Design. So here we can see our work plane, and for the first part we're first going to look at the different angles and how the camera works in Tinkercad. So if you scroll your mouse in and out, you'll see that your work plane zooms in and out. This little box here at the top left corner is very handy, and it's because you can view your work plane from any angle. So let's place a cone for now so that we can view our cone from different angles. How do we place a cone there? We click on the cone and we drag it to wherever we want it to be in the work plane. So if we want to view this cone from the top, we just click on top. If we want to view this cone from the front, we click on front. From the right, or from the left, or from the bottom. So let's just get it back to where it was. So we just click on this little line over here. Okay, so we have our cone in the middle of our work plane. Let's see what we can do with our cone. Okay, so if we click on our cone, we can see that we have two options, either a solid or a hole. If you click on a hole, it will appear in this color, and it will basically, in this case, just be nothing. So let's keep our cone solid. And we can change the color of our solid as well. So let's make our cone red. Okay. With these options here, we can change the top radius of our cone to the size that we want it to be, but I'm going to keep it to 0. The base radius, I'm going to keep it at 10. And we can change the height of our cone. Let's just make the base radius 20. And we can also change how many sides we want on our cone. Let's just make it the maximum number of sides so that the sides are smooth at the bottom. Okay, so this is our cone now. But let's say we wanted to drill a hole through our cone. So what are we going to do? Let's first think, what is the shape of a hole? The shape of a hole is sort of like a cylinder. So we're going to drag our cylinder here. And now we have these two options. So let's select the hole feature. And if we look at our cone from the front, we can see that if we were to use this hole feature, it's not going to cut through the whole hole, through the whole cone. So we need to increase the size of our cone. So what we do is, let's just go back to this view. We take this button and we drag it so that if we look at the front again, we can see that our hole is a bit higher than the top of our cone. Okay, perfect. So what we do now is, let's first make the hole a bit smaller because it's quite big in relation to our cone. So let's make it a 10 by 10 hole. And let's drag our hole to the center of our cone. And let's just see what it looks like. Yeah, that looks like it's in the middle. Okay, so what we do now is we're going to group our features so that this hole can cut through our cone. So you just click here and select both of your objects and click on the group option. And then you'll see, if we look at it from the top again, that there